for the introduction. Dr. Pat Dooley is my name. I'm co-PI and research director for RFID, IOT and sensors in the IMaR technology gateway based in IT Tralee. I suppose you're right in saying that they're all the buzzwords, but those buzzwords have been around a while and we've been waiting for them to become popular for about 10 or 12 years, so hopefully now is the time. I guess for us, as I say, we have been working on particular RFID projects since 2002, 2003, right across Europe, with various different partners, which may seem a little strange to some out of somewhere like Tralee, but really I guess we're at a stage now where it really doesn't matter where you are. What IMaR is basically, it's what we would like to say, it's Ireland's leading intelligent mechatronics and RFID industrial partner. Mechatronics, as you're aware, is the marriage of mechanical and electronics, and Danny here with me will be able to tell you a little bit more about that. Whereas, I suppose my side of the house has much more to do with RFID and IoT, and purely from a data collection perspective. I think that we're all talking about Industry 4.0 at the moment, and it's great when the buzzwords do appear. Internet of Things, Internet of Everything, Industrial IoT, you name it. Okay, there's a buzzword to it. But at the end of the day, what we need technologies that help and that provide solutions. And basically, all of these are either gathering data or where we sensing something or measuring something, which we can then analyze and give a solution. So IMaR, and very briefly, is part of a technology gateway structure that Enterprise Ireland have set up. We're down here in Tralee, but there's gateway all over the country that have different specializations. So ours, as I say, is in intelligent mechatronics and RFID. We also work in sensors, data analytics, software, all the parts that you require. There's 12 gateways, and as I say, I'm not going to go into it in great detail. There's an Enterprise Ireland stand here at the show, and they can tell you a little bit more about the other gateways. For the purposes of this, we're interested in what IMaR can offer. So, I suppose, in terms of Industry 4.0, and I'm sure everybody here has read about it and heard about it, but the driving force here is cyber-physical systems. And cyber-physical systems, I guess, is where things get sensed, where things get connected, where data gets collected, and data gets analyzed. Lots of the time we're connecting solutions that have been around for many, many years. I mean, if we're talking about automation is not new. Sensors are not new. RFID is not new. A lot of the technologies underpinning Internet of Things are not new. However, infrastructure and computing power and software is allowing a lot of these things to come together to provide integrated solutions. And I think that's really the key. So what we're looking at here, I suppose, is, as I say, an integration of multiple technologies that have a history. And some of those are in that there from BCG. And so if you look at it, I suppose it really covers everything that's in IT and engineering. But you've got big data and data analytics, you've got autonomous robots, simulation, integration, Internet of Things, security, the cloud, additive manufacturing, and augmented reality. And all of those, in some guise, have a role to play in the factories of the future, or Industry 4.0. From an IMaR perspective, we have, as I say, you would say that RFID was the precursor to what's now being called the Internet of Things. When it was mentioned about buzzwords, my own background is in mathematics, and my PhD is in neural networks, which is now the buzzword again. It was the buzzword when I did my PhD, but 20 years later no one wanted to hear about it, and now it's great again. RFID is probably quite similar in that now no one's really talking about it as a technology because it now works. And neural networks is probably the same. What I would say about IMaR and our role here is we are an applied research centre. We are not an academic research centre. Yes, we have an academic wing within IT Tralee, where obviously you've got to improve your technologies, your skill sets, create your experts. However, our role as IMaR is applied research, and that's where we go. We take the technologies that we know work, that companies don't have the expertise in-house, and we apply those technologies to solve use cases that companies have. Our experience is that the vast majority of manufacturing companies are busy making things and trying to sell them and get them out the door. They don't have time, or the expertise in-house to put sensing systems in place, to use neural networks, or go learn about them. So what we do is we try to mitigate that risk through funding mechanisms that Enterprise Ireland provide for us, and we do projects. But those projects are not about having a report at the end and saying, there you go, that's 2 years' work. It really is about handing over solutions, either finished or in a position where they can be taken to somebody to finish them off over a period of 6 months or a year. That's really where we're at in terms of a research group. I'm going to hand you over to Danny now quickly, but basically we came from two groups. We came from a SIMS group, which was an engineering group, very much in the mechatronics, electronics, automation space, also based in IT Tralee, and SIDS, which was an RFID, artificial intelligence group, which was headed up by me and co-founded with MIT. And those groups came together because it made sense. It made sense from a perspective where you need engineers to go and do the sensing, to do the automation, to do the implementation, and you need people with software background, with analytics background, and now with AI background in order to consume that and turn it into something useful. Okay, so I'll just hand you over to Danny. Thanks.
Hello, Dr. Daniel Riordan I'm the Centre Manager, Technology Gateway Manager for the IMaR Centre. I was going to talk a little bit about the transition, kind of where we fit in. The transition, I suppose, from Industry 3.0 to Industry 4.0. Probably like a lot of people, I didn't really hear of Industry 3.0 until I heard of Industry 4.0. I didn't know anything about it until it became a buzzword there a couple of months ago. Apparently there was an Industry 3.0. And we were doing it. We were all at it. I suppose the lot of, I'm just going to skip ahead in the slides a little bit. Just to go into this a bit. Process automation. Everyone was automating their process. Industry 3.0 was about banging stuff out really quick. Easy jobs. Grab the low-hanging fruit. Automate it really quick. Do stuff fast and do stuff really cheap. At the end of 3.0, people started getting in from high-value products, particularly focused for pharmaceutical. People started looking at process analytic technology. That's real-time monitoring of your process. Real-time looking at it and then changing the parameters on the fly to make sure your product is coming out bang on. Before this, again, aimed at the pharmaceutical, they were doing batches. They do a batch of tablets, maybe, I don't know, a million Panadols or something. Then they test them, they're a little bit dodgy, bin the lot. That's no good. So started monitoring it in line. If the temperature in one particular section, thousands of processes, one particular section is a little bit off, that can be a key quality indicator. That particular temperature, if that has to change immediately, we might only lose a few hundred tablets. That's where that came in. And that was really coming to the end of 3.0, but it was starting this 4.0 that we now know as 4.0. So 4.0 is about doing stuff, doing both of the things. Doing stuff cheap and fast, but keeping the quality. Keeping the quality. Okay, so just kind of going back, and we'll come back into it again. Just go back to a project we did with Dairy Master. It was an FP7 project. What we're trying to do here is automate the process of putting clusters onto cows. Dairy Master do high volume milking. They don't do the one-off milking units, robotic milking units. They don't do that because it's slow. They want to do larger rotary parlours. There you can have 100 cows milking at the one time. The cow milks in 8 minutes out the door. They have an operator putting it on, okay? But the labour is cheap. It's not a well-paid job. Being a farm operator, not a well-paid job at all. So a lot of times, why would you automate it other than maybe a high-paying economy like our own? But it's really slow. So you can get a person to do that, a low-paid person, to throw on milk cups at about a cow every 2 seconds. Throw them on. The reason you want a robot to do that isn't because you make a huge amount of money doing it. There is savings to be made in that regard. You make a few savings in higher paid economies. One of the main drivers there is quality. If you have a very low-paid person, they have to do a few jobs, not just throw these things on. They've got to disinfect. They've got to decide to make it ready to give milk. They have a few things to do, and if they don't do them all, the cow isn't milked out properly. It's a quality issue. which a robot can improve. Not necessarily do it faster or do it better, but it can do it to higher quality because you know what it's done. You know exactly what it's done. And that's where this is coming in to 4.0, to the PAT technology. 4.0 is really coming into process analytic technology and flexible operators and robotics. You see here, there's a few companies, they want to pick universal tracer, universal robots, universal robots. They make assistive technology. Now with assistive technology, it's usually for very complex jobs that you really can't automate 100%. So you have to put, I don't know, you have to put a fastener in a really awkward position. A robot may not be able to do it because you have to augment the thing around. But an assistive robot can do it because a person can augment the unit around and the robot can do fastening or the gluing or whatever needs to be done. Now the benefit in that is that when a person does it, they may have to take a paper box saying, I did this, I glued that thing. The robot will do it automatically. You can automatically take a picture of it and you know it's done it. Robots don't lie. So that's the whole idea of 4.0. 3.0 is really it speeded things up. Automation is all about speed and profits. 4.0, it's bringing in cyber-physical things, so it's also monitoring what it's doing itself. Realistically, for a high-value product, if a robot builds it, even with the help of a person, or even if a person does it, there can be a robot keeping an eye on what it's doing. 3 years later, that fails in the field. You can go back, check it up. There might even be a picture of that glue joint in place that you can say to the person in the field, we actually did that. That's not our fault. We did it. Somebody else's problem. But that's where we're really getting at 4.0. So that we have projects coming in on this. This has applications in ag food, manufacturing, automated manufacturing. You'll see it even has applications in tourism and automation. I wouldn't really think of it. ICT software, these are areas we've worked in the past. Logistics is a big one for Industry 4.0. It's just another link in the manufacturing chain. Driving on with that, we're working on, Pat said earlier, I won't go into too much. We're an Enterprise Ireland funded. It's our job to engage with small companies to large companies, companies developing their first prototype to multinational companies, work with them to develop projects. We work in automation, data analytics, process control, RFID, IOT, that kind of thing. We use Enterprise, we can leverage Enterprise Ireland funding. We help with the application process, all that kind of thing, to work with these companies in the past, hopefully new companies that